Hello. Hi. Today we are going to look at how silicon can be used for various application in construction. Essentially, this is a material which has been developed 70 years ago, but it has been a significant development and the innovation which has gone into developing this material has resulted today in using this for architectural applications. I am Ravi Shankar. I am a polymer technologist from UDCT. I have an overall industrial experience of 23 years, out of which 15 years is in construction division. So I work for Dow Chemicals International, and this, if you all remember, has been Dow Chemicals has taken over Dow Corning last year. So, and Dow Corning has become part of Dow Chemicals now. So, with this brief introduction, I want to take you through some of the important application development what is gone in using silicon for architectural applications. Essentially, for the facade, if you talk about, there are three main components which are being where the silicon is being widely used. One is called structural glazing. It is the method of bonding a glass to the frame using a silicon, and then the silicon takes the load. And second is the thermal performance, which can also be designed through having a insulating glass. Again, for the hermetically sealed insulating glass unit, silicon acts as an important and integral part of the insulating glass unit. And third, last but not the least, on the facade or any application, weather seal is one of the critical joint design, which is going to impart significant amount of criticality for the watertight seal. So I will take you through some of the details around this, and also I'm going to take you through some of the applications which are going to be very new, which has been introduced with silicon. So my agenda for today is going to cover, one is introduction to silicone sealants. We are going to talk about structural glazing, insulating glass, weather seal, design, application and quality control. We are also going to talk about industry standards and references, which are the standards which talks about this particular application today, and what are the references and how durable the system is. We are also going to talk about what is essentially needed for this sort of an application to be supported with in terms of services part. So before we start, just to give you a brief idea, if you all know or if you do not know, the silicons are again a synthetic polymers. Okay, they are abundantly available in the earth crust in the form of a quartz sand, and from the quartz sand it is mined and then it is being converted into a silicon metal and for an electrical arc process, and from the silicon metal to a silicon polymer like any a big distillation column or a petrochemical plant size, where the silicon polymer is made, and this silicon polymer becomes one of the integral component for making various products used for variety of applications including constructions. So this is one of the important thing to understand is a quartz is the original raw material for making silicon, which is available in the earth crust. So this is a process which really talks shows how the total basic train or how the silicon is being made. So it starts from the silicon metal like a lump, and then it is grounded to form a ground silicon, and this is then added with a methyl chloride, where there is a mix of and with a catalyst it gets converted into chlorosilane mix. This is then distilled, and it has been distilled according to the melting points and the boiling points, and then this is done through the distillation column, and the byproduct what is coming out can be recycled, and the main product which comes out of this is a siloxane polymer. Okay, so there are two things which are used as an integral material here. One is the ground silicon metal, and then the methanol which has been added to that, so which is again converted into the methyl chloride, which is then resulting into the formation of polydimethyl siloxane. So this is a polymer which comes out of this process. There are only very few manufacturers in the world who has the capability to manufacture from this basic process of manufacturing siloxane. So it must be a point for you to really understand, because when you go to the market, probably you will find n number of brands coming out with their own product. So it is not that they are all the basic manufacturer of silicon polymer. They always buy the polymer from somebody like who are the original manufacturers of siloxane, because they can sell this polymer into the market, and depending upon the requirement, the polymer has been bought and converted into different products, and one of the product is a sealant. Okay, so that's the reason the formulators or the compounders who buy the polymer and then convert that to the finished product, that's the reason you find many brands available in the market. So the difference between the original manufacturer is the original manufacturer can control the entire quality control process compared to the one who is the compounder or a formulator who just takes the material and then converts them into the finished product. So this is just to give you a basic idea about who is the original manufacturer and how it starts from, and also to give you an idea about the compounders and where they start from. Okay. So this final polymer which comes out can be converted into different forms. Okay, this can be formed like a fluid, this can be act like a dispersion, so like an aerosol, or it could be an emulsion with a water based system, or it can be also made into a grease type of a compound like a lubricant, and by doing cross-linking polymerization you can make it to a gel, or you can convert it into a resin, compound or elastomers or rubber. So the essential form of the sealants which are being used for the construction applications comes from the elastomers or rubber part of it. So we are going to go into the details of this particular chemistry. And also just to give you an overall view of where the silicon can be used, is it can be used in multiple applications. So it will be interesting to know. So it can be also used for beauty and personal care or home and personal care applications, where it can be used in the deodorants, moisturizers, or perfumes, or it can be used in gels or the hair shining ointment. So whatever we are talking about, the essential personal care, those have got some amount of silicon added to that to give a good wettability, shining, and also avoiding an grease feel. So it's not only in that particular segment, it is used in food and beverage, electronics, chemicals, solar, or you talk about any of the household appliances, automotive, oil and gas, or any packaging or textile. So into industrial applications like home and consumer goods, or even in assembly and maintenance. Not only that, it is also used for the healthcare applications. The chemistry is so beautiful that it can be used by formulating it to behave exactly in an opposite characteristics. Some of the interesting thing is in the construction applications, we want silicon to bond. Okay, we never want the silicon to leave any of the substrate where it is applied. Whereas essentially, if you look at some of the packaging applications, it acts like a release. Okay, so the release coating which is applied on the liner behind the stickers is coated with silicon, and it acts like a completely a release. So that is the beauty of this chemistry, that it can give you an exactly opposite properties. So and it's a versatile chemistry which can be formulated and to suit different applications. So to understand the beauty and depth of this chemistry, I'm going to take you through some of the old school what we have seen. We might have read in schools about silicon and organic. So I'm going to take you through some of that now, but I'm not going to really drill down into the chemistry part of showing you the formulas and making you answer me, but I'm going to talk to you about the basic difference between what is silicon and what is organic. So if you really see from the first slide what we talked about, silicon is a material which is coming from the quartz sand. Okay, so it's a material available in the earth crust, like an inorganic compound. So this is an inorganic material which is mined from the earth, and then it is converted into a polymer. So the essential difference is organic polymers are generally made out of like you can take from the petrochemical or the crude oil chemistries, so where it is cracked and converted into carbon. So organic chemistries are mainly carbon based, whereas silicon is SiO, which is a basic backbone, and that's an inorganic chemistry. It has got side chains which are organic, but the essential backbone is coming from SiO. Okay, so we are going to talk about what is the main difference, what does it really help, or does it really help, or what are the complications or the implications, and we are going to look at what are the essential properties this is delivering. So if I tell you about organic in terms of chemistry, the products which are being used for the adhesive applications are generally polyurethane, polysulfide, acrylic or epoxy. So you may be traditionally, you can, if you know the chemistry, you can also relate them to the brands available in the market. But not, just to quote so that you get a feel of the chemistry, like we all know araldite because that's one of the powerful brand available in the retail. So that's an epoxy. So similarly, if you talk about different commercially available products, so you can relate them to the chemistries. The one which is available as an inorganic is a silicone sealant, and it comes from various manufacturers like Dow Corning or Dow Chemicals, or other manufacturers like Momentive or Sika. So these are some of the brands which are predominantly known in the market. And again, this is to give you an overall feel of what is inorganic and an organic chemistry perspective. So what does it really mean in terms of chemistry is, when you talk about high performance weatherproofing materials, silicon oxygen, the bond, which is the backbone of an silicone sealant, has got an energy of 450 kilojoules per mole. Okay, so if you see, for any external applications, there is going to be a sunlight which is falling on it. A climate like India, we will have 365 days of sunlight. Okay, it is hard to not to have sunlight, as in leaving aside some very few times of monsoon, but still it will be bright, and sometimes you get to see the sun. So what is happening essentially here is, when the sun is falling on it, or then there is a UV component of the sun which is falling on a particular material, so UV has got an energy of 400 kilojoule per mole. So this particular energy can degrade whatever is lower than that. So that's the simplest way to understand. So if you talk about organic chemistries, their bond energies are lower than the UV light energy. So essentially they can be degraded, but they do stabilize them by using an external stabilizer which has got a limited life. But if you look at silicon, the silicon polymer has got an inherently stable backbone. So this is essentially giving it an inherent stability against the exposure of against UV in the sunlight. So this is one of the key differentiator. That's the reason you can find this particular chemistry has overtaken the many of the other products which are from the organic for external applications. So in external applications, what we want is any product which is exposed to the UV, so sunlight is falling on it, so the UV that the product should have a good resistivity or stability against the exposures. Nobody wants to apply a product wherein somebody says that you use my product, stick the glass, but what you need to do is after every 5 or 7 years you need to remove it because the product is going to degrade. This would not have really given the product or this technology to move so much higher. So the essential reason for this has become a very large success in the market today is because of the durability against exposure. It's not only against the sunlight, it has got an excellent resistance against water, weather, and also acid rains or rains. So it has got extensively very good stability against most of the weathering properties. So that is the reason this chemistry has proven much more durable and long lasting than the other chemistries which came before the silicon chemistry. So I want you to really understand this particular slide, because this gives you an overall view of why you should use a silicone sealant versus an organic sealant for an external applications. There are few applications wherein since because there has been it's coming from a different climate like in Europe or any other climate where they don't have much of an they may not be having such a sunlight or an UV or weathering what we have in India. So you might tend to see in some of the applications still organic has been used, and we have seen it that for a climate like ours it gets degraded. Even in India, people have used this as a product for some of the applications like even insulating glass, and we have seen cases where the outer pane of the insulating glass has fallen down within few months or in years of time when in this exposure to UV had converted them or degraded them. Okay, so that's the reason now silicon has become very popular, and if you really see This chemistry has been used in construction for more than 50 years, essentially on the structural bonding for the glass for more than 45 years. So that's the case history what we are talking about, so which is proving that this chemistry is a right chemistry and a very durable chemistry to be used for such application. And it's not only just the durability, but what it comes out is, along with the durability, it also gives a sustainability. Okay, so essentially any product which is less durable has to be redone every now and then, so there is going to be a repeated consumption. So what we achieve from silicon is by having a long lasting and a good durable life, so you are able to save 3 times carbon credits, or less, you don't essentially put the carbon greenhouse gases emissions, you can save 3 times compared to that organic chemistry. Rather, silicon save 9 times more than CO2 than they create. Okay, so that's a punchline, and you can Google it. These are all very well available informations on the net. So essentially, you are connecting to a chemistry which is also giving you a good carbon balance, and this can also be supported by getting some of the LEED certificates from the leading manufacturers for their products. So if you are going for a gold, platinum, silver or any rating, if you essentially want how your materials are behaving, and because of that you get additional points. So with using silicon you can get an additional point, because this is not going to give you the volatiles, and which is going to be much lesser than what it is needed by the regulations. Okay, so coming to now we have understood the difference between silicon or with organic, and we have also understood how the silicon is made. So now we are going to go into the details of what is a silicone sealant is, because this is the product which is going to be used for construction application, widely for our facade, essentially a structural glazing, insulating glass and weather seal, and also other applications. So the essential thing again here on this slide, what is needed to be understood is the silicone sealant is made with a lot of material added to that. So one of the main thing what is really making the property of this particular product impacted is the polymer. Okay, so the siloxane polymer, we saw that, so that polymer has to be added to make the sealant. So the amount of polymer added varies the properties, and this is an essential backbone which gives a very good mechanical, physical as well as other important properties for the product. So you have to cross-link them, because this is going to be a cross-linked rubber what you get. So for cross-linkings you need to have different cross-linkers which has to be added. So there is a polymer chains, so you need to cross-link them to make it as a matrix. Okay, so the cross-linkers are added. These are again siloxane with the reactive ends. To make this reaction happen at a faster pace, at the right pace, catalysts are added. So the catalysts are added, and this actually takes care of the rate of cure. Okay, so the curing rate has been controlled by the catalyst. So that is the reason when I talk about in my further slides, I'm going to talk about what is that which is very important when you use the product or when you keep the product in shelf. Okay, the other thing which is also giving some amount of mechanical resistance to this particular material is the fillers. So the fillers are essentially different types of fillers with different forms have been used, which is actually acting as a reinforcement. So this improves the mechanical properties of the product. So the mechanical properties like the tensile strength, shear strength, so those are the properties which are essentially given by the filler. So but as you all know, there is an amount of addition of the filler going to reinforce. But you add more and more, you can make the product bulkier, or you can make it more with the filler so that you can reduce the cost. So by compromising on the polymer or other contents, you can add more filler. So what is important to understand is you should have a balanced chemistry of additives which are added to make this material. So you can make it imbalanced by adding some or other more to make it cost effective, but then the application of that product needs to be understood clearly that this is not a product which is meant to be used for an application where it has to be designed to take loads. So we need to understand, and then we need to approach the manufacturer, take their guidance of using what product to be used for which application. So for the sealant to dispense, so it has to flow at a particular rate. So normally the extrusion rate, that's what it is called as. So it should have a minimum extrusion rate of, say, in one component around 200 grams per minute. Otherwise you will not be able to fill or apply the sealant into the joint. So there is some amount of plasticizer added to make it happen in most of the products. But you can do that with a special type of polymer selected and make it non-plasticized, essentially for certain applications where you are looking for a non-staining or a non-bleeding with the seals. So there the plasticizer can cause a stain. So this plasticizer otherwise added to the other general products is a non-reactive fluid. This is not going to react with the matrix. So this will be separate and it will come out with time, and it can potentially stain or streak. So depending upon the amount of plasticizer added, you can see some of the facades having the black line running down from the joint. So this is essentially because of the non-reactive plasticizer coming out of the sealant due to movement, and then the dirt and dust which gets deposited, they can make it look black. And other important additional special additives also are very important. One of the ingredient which is added is adhesion promoter. The sealant has got a good bonding characteristics to many materials, and this can be further enhanced by adding an adhesion promoter. So this ensures that the product bonds to various substrates. So as I told you, the essential property of silicone sealant for construction application is to bond. So the intended applications what we are looking at, we want the silicone to bond and take loads or take movements. So the adhesion is very, very important. So the adhesion promoters are added as part of the ingredient, and this helps in getting good bonding to the substrates. And some of the essential additional features for the product can be obtained using special additives. So some of the applications, like a moist area where you have a bathroom or a kitchen area, you are looking at an antifungal sealant. You don't want any mold growth to happen or mildew or an organism to grow on that. You want essentially that to be an area of moist area where it's prone to hot and humid climates or water, so you don't want the growth to happen. So special additives like fungicides, some colors to get a good different shades in the sealant can be obtained by adding pigments. So this is an essential ingredient slide. So the silicone sealant comprises of these materials. So what is also a takeaway from this slide is these are needed, but you can always vary them to get a formulation to make it right for the application or make cheap, and then it can be used for a wrong application and it will not give you the desired properties.